So one thing that you might be thinking about is when we solve problems using linear functions or quadratic functions, oftentimes you have to plug in values for x. But looking at an example like this first one, it's going to be pretty difficult to plug in numbers directly and figure out what x is, because we have pretty big powers, reasonably large coefficients. So we actually have a tool that's really useful called synthetic substitution that allows us to figure out relatively quickly a value. So let's say we wanted to find out what f of x is when x equals 3. So I'll write that equation down here again. So f of x equals x to the 5th plus 3x cubed minus 2x squared plus 7x minus 2. So the way that you apply synthetic substitution is you first want to write down the coefficients of all of the different terms in the polynomial. So the coefficient of our leading term here is 1, so we write a 1 down. Then we write a 0 down. Now, why are we writing a 0 down? Because even though we don't have an x to the 4th term right there, 4 is sort of the next possible power of x, but because we don't have that term, the coefficient there is effectively 0. So we write 1, 0, then a 3, then a negative 2, then a 7, and then finally a negative 2. So you would put that 0 there. So let's say, for instance, if we didn't have this negative 2x squared, instead of this negative 2 here, we would put a 0 there. So you never want to skip a possible degree. You just put a 0 there if you don't have a term of that degree in between. So we have all of our coefficients here. We have 1, 0, 3, negative 2, 7, and negative 2 again. And then over here, if we want to find out what f of 3 is, for instance, we'll put a 3 in this little box. We draw a line down. And the way that it works is pretty cool. So we take this 1 here, we bring it down, and then we do 1 times 3. Okay, that gives us 3. 0 plus 3 gives us 3. Okay, maybe you can see the pattern already. We'll do 3 times 3. Okay, that gives us 9. Okay, then we have 9 plus 3. That gives us 12. Okay, then we do 3 times 12. That gives us 36. Okay, 36 minus 2 gives us 34. Okay. Then we'll do 34 times 3. That gives us 102. Okay, 102 plus 7 gives us 109. 109 times 3 gives us 327. Okay, and 327 minus 2 gives us 325. And because this is sort of our number in the last space, this is our answer. So that means that f of 3 is 325. Okay, now if we wanted to double check that, we can plug it in on our graphing calculator. So we do f of x equals, let's see, x to the 5th plus 3x cubed minus 2x squared plus 7x minus 2. We hit graph. So we notice we have this kind of bendy graph here, and it goes way, way up, even like a little bit past 1. It's out of the range here. So why don't we zoom our window out a little bit? We'll still go from negative 10 to 10 for x, but for our maximum y value, why don't we bump it up to that 325 that we got, or maybe we'll make it 330. We'll make our scale go by tens. We hit graph again. And notice here at 3, we're way up there. And just to double check, we can calculate the value when x equals 3, y equals 325. So a pretty cool technique that gets you the answer a lot faster than if you tried to plug in 3 for each of these and find the answer that way.